All right, so we're going to go through the Chapter 6 problems. So the first problem is Clobeck solution contains 5%, or well, 0.05% weight per volume, clobetasol propionate in 118 milliliter containers. Calculate the content of the drug in milligrams. So I would take and do this as a proportion. So we know how much the full container is, and we know how much our percentage is, and we know that that's the 100%. So X. So you cross multiply 0.05 times 15 and then divide by 100. 0.059, which is 59 milligrams. When you multiply this by 1,000, when you convert this, because this is grams. And then you can do it a different way, which is 118 times 0.005. No, there's one more zero. And then that will find you 0.059 grams. And that's also going to equal 59 milligrams. There's our answer. All right, so I wrote this out two different ways so that you guys can tell what I would normally see on a script. So it would be 2 GTT into OU Q4A 2D, then 2 DGT Q6 hours 4D. So this is 2 drops into both eyes, but in the original script it just says eyes, every 4 hours for 2 days, then 2 drops every 6 hours for 4 days. But they don't necessarily want that. They just want to know how many milligrams are in the solution. So all of that is unnecessary. So do it proportion-wise. So we know that the whole entire thing is 10 milliliters. We know that that is 100% is at 10 milliliters. And we know that we have 3%, 0.3%. So cross multiply, which is 10 times 0.3. Oh, no, I accidentally. And then divide by 100. That equals 0.03, which is 30 milligrams, because this is grams. And so the other way that you could do it is 10 times 0.000, no, 3 equals 0.03 grams. And that also equals 30 milligrams. If 100 milliliters of a pharmaceutical preparation contains 20 microliters of a 50% weight per volume solution of benzyl cam, I probably mispronounced that, chloride, what is the percentage strength of that in the solution? So first off, you have to take the 20 microliters and find out how much there actually is, which is 10 microliters because it's half of it. So that's your first step. And then 10 microliters, I'm going to convert that to milliliters. And that should be 0.01 milliliters. And then that is 0.01 milliliters divided by 100 milliliters, because that is what our total is. And then that will equal 0.0001. And that is divided by 100, or multiplied by 100, and then that is that percentage, and there is our answer. Sorry. So that for a second. All right. A biotechnology company makes the drug interferon gamma 1b, Actimmune, contains 100 micrograms per half a milliliter. Calculate the percentage strength of the solution. I must spell calculate. So I would take micrograms and convert it to grams. So there's 1,000 micrograms for every milligram, and there is 1,000 milligrams for every 1 gram. And so that would equal 0.001 grams. And then we take, writing this backwards, and then we take that over half a milliliter. Equals 0.0002, and then multiply it by 100 to find the percentage, and that is your percent strength of your solution. All right. Calculate the percent strength of a injection that contains 2 milligrams of hydromorphone hydrochloride in each milliliter of injection. Okay, so I would first convert this to grams because your percentage strength is always in grams over milliliters. And there's 0.2 grams for every 1 milliliter. That's going to equal the same. I don't know why I put that in there. And then multiply it by 100. You find that is 0.2%. Okay. What is the percentage strength, volume per volume, of 225 grams of a liquid having a specific gravity of 0.8 is added to enough water to make 1.5 liters of the solution? So we know our total, and so we need to change this to milliliters. So we know that there is 0.8 grams per every 1 milliliter of solution. So that is nope. 25 divided by 0.8. All right, 281.25 milliliters. And then so we know the total of the solution is 1.5. So that would be the same as 1,500 milliliters. So zero 0.1875, and that would be 18.75%. Okay. All right. Oh, wrong way. How many liters of mouthwash can be prepared from 100 milliliters of cinnamon flavor if its concentration is to be 0.5% volume per volume? So we know the amount of cinnamon that we have, and we know the desired percent is that out of 100, 100%. So cross multiply, and it's 100 times 100 divided by 0.5. So 2,000 milliliters, but they're asking for in liters, that is 20 liters. So there is your answer. All right. Each gram of Lortizone lotion contains 10 milligrams of clotrimazole and 0.643 milligrams of betamethasone dipropionate. Calculate the percent concentration of each of these two agents in the lotion. So, we know that there is 1 gram of lotion, so 10 milligrams. I'm going to convert that to 1 gram so that it is in the same. So that is 0.1 gram. And then if we take that over divided by 1 gram, that's going to be 1%. So that is for the first one. Let me change colors here. And then 0.643 milligrams. Convert that. And that is 0.000643. And so when you take that over 1 gram, and then you have to multiply it by 100. So then that is 0.0643%. So there is that, if that makes any sense. A hemorrhoidal ointment contains a weight and weight basis, 46.6% mineral oil, amoxicillin 1%, and then 12.5% zinc oxide. In an ointment base, calculate the grams of each ingredient, including the ointment base, in each 30-gram tube. So we have to find the ointment base percent because we don't know that yet. So we're going to add 46.6 plus 1 plus 12.5 Oh, sorry, it's 12.5. Oop. 60.1. All right, so 100 minus 60.1. All right, so this equals 60.1. And then you take 100 minus 0.1 and you equal 39.9. And that is our ointment base. That is the amount of it. You could almost say that the mineral oil is the ointment base because it's the largest percent, but I'm not going to argue. So the first thing I see is that there is a 1%. And so the way that I would do this is take the 1% over 100% and then take the 30 grams because we know that it's 30 grams. And you find that your X equals 0.3 grams. So then you just take your 12.5 times 0.3, and you take your 46.6 times 0.3, and you also take your 39.9 times 0.3. Otherwise, I would set it up, all of them, like this. So times 12.5, 3.75 grams. And 46.6 times 0.3, 13.98. And then 39.9 times 0.3, 11.97. And then I want to add these all and double check to see if they all actually add to 30. So 0.3 plus 13.98 plus, so 11.7, 3.75, 3.75. And they in fact equal to 30. So our calculations add up. So that means that we have our ointment base, our mineral oil, our pramoxine, and we have our zinc oxide. So we have all of our ingredients. So if we were asked in a situation where we were actually compounding, we could actually find out what everything was. So this is the same thing, except it is done in A, B, and C instead of just finding it all. So what is the percentage concentration of progesterone in the solution? So our solution total is going to be 100 milligrams. We have 4 grams divided by 100, or milliliters. So that equals 0.4, 0.4. So that is, do this, it's easier to see, which is 4%. So that is part A. And then what is the percentage concentration of weight per volume methyl cellulose in the solution? So this one's a little bit trickier, not that much trickier, but trickier. So you take the 50 milliliters and you have to find the amount in the 50 milliliters. And so it's 1%. So then you find 0.5 milliliters is actually of the methyl cellulose. And so then that divided by 100 is 0.5%, because you're just going over 100. So that is that one. Okay. And then this one is, what is the percentage concentration of volume per volume and weight per volume of glycerin for the prescription? Well, so if it's 5 milliliters, it's going to be 5 milliliters over 100 milliliters, and that one's going to be 5%. And so it's kind of like this one, where it was 0.5 milliliters over 100 milliliters. I should have probably written that out. And so then we take 5 milliliters, 1 milliliter, 1.25 grams equals 6.25. And then 6.25 divided by 100 equals 6.25. Okie doke. And we have number 50. Next one. This one is easy. So you would take 1,500, you divide it by 100. 1,500 by 100 equals 15. And then that is your 1 out of 15%. So then, oh, okay. 5 by 15. 0.06, and then it's repeating percent. So then that is a, well, then you do that for all the other ones, which is 100, 1 over 100% is 0.01%. And C is 250 by 100. It's 2.5. 2.5%. What? No, that's, sorry, yeah. 0.4%. One over 4% is the same as 0.25%. And then we have 3. Oh, put that down there. All right. And that is 33. 1 over 33%. This one. Okay, since it has one more zero, that would be 0.025%. So does this one make sense? I think it's a pretty straightforward one. A doxycycline calcium syrup is preserved with 0.08 weight per volume methylparaben, 0.2% of polyparaben, and 0.01% of sodium methyl sulfate. Express concentrations and ratio strength. So I'm going to lay this out a little bit better. So we have 0.08%. One, then you divide both sides by 0.8. You find that this is 1. This is A. That's your methylparaben. Make this A, B, C. So 1 divided by 0.08 equals 12.5, and then you multiply that by 100. So 1250. Okay. And then so that is first one. And then B is 0.02 over 0.02, 0.02, 50 times 100, 5,000. 1, 2, 5,000. There's that. And then 0.1. Yeah. Divided by 0.1 and multiplied by 100,000. All right. In acute hypersensitivity reactions, half of a milliliter of 1,000 to 1 weight per volume solution of epinephrine may be administered subcutaneously or intramuscularly. Calculate the milligrams of epinephrine given. So we know that this is the ratio, and so want to cross multiply. So half times 1 is the same, divided by 1,000 is x equals 0.0005 grams, because your weight per volume is always in grams, and then you multiply that by 1,000 is 0.5 milligrams. The other way you could do this is that you could see that it's 1 gram per 1 milliliter, but it's in 1,000 milligrams per 1 milliliter. So you would convert that to find it. And so you'd have 1,000 to 1. Well, then when you go over to convert it over here, it's a 1 to 1. And so you would find that, half a milliliter is equal to a milligram. So that's another way that you can recognize it, but it might not be so self-evident. And I think that's the end of the questions. Yep. So that is how you do these questions. I hope I was pretty coherent. And if you have any questions, ask Dr. Sadig. I am not technically the expert, although I am trying to be. All right. Have a good one.